It is about how much of the fluid pass through a cylindrical tube. So imagine a cylindrical tube like this. Whenever a fluid is passing, as I said earlier, it moves like different sets of layers because they have a kind of proximity and move together, right? So these are different sets of layers like first layer, second layer, third layer, fourth layer, where the fourth layer is the bottom layer here. While the first layer moving in a forward direction pushes its next layer in a backward direction. So the first layer is the most comfortable layer who moves smoothly and with more efficiency, the higher speed. But the second layer, because the first layer is pushing it back as a reaction, have a speed, if say it is V1, it will have a speed V2 that's less than that of V1. But look at the third layer, that being pushed back by first layer as well as the second layer. So it will have a velocity V3 even less than that of V2. Similarly, the fourth layer will experience opposition due to all the upper layers 1, 2, 3. So it will have a velocity even less than that of the third layer. Thus, the bottommost layers in a viscous fluid will have a lesser and lesser velocity and almost in a kind of a stagnated state. Because of all this, how much of the fluid passes through the cylindrical tube, how much of the volume of the fluid passes to the cylindrical tube per second is being identified by the scientist Poiseuille. He has derived an equation basing on experimental observations, but we will try to derive it basing on a say units and dimensional analysis. So what he found is volume of the fluid that is passing through the cylindrical tube or for a viscous fluid is directly proportional to, and hence I am putting a constant some k. He said that is directly proportional to or it depends on pressure gradient. Pressure per length is called gradient. Anything by length is generally called like a gradient, like pressure gradient. So I don't know by how much power it depends, so I will call it like power A. I have to find out that. It also depends on coefficient of viscosity, that's the viscous nature of the fluid. Its coefficient is not yet known, so I'll call it like B. It also depends on the radius of that cylindrical tube, C. So though Poiseuille has derived it experimentally, we are deriving it based on dimension analysis. As per the principle of homogeneity, the left-hand side dimensions of this equation shall be equal to the right-hand side dimensions. Let's write dimensions first. Volume, L cube by time, that is second, equal to K is a constant, it won't have any dimensional formula. And then pressure. Pressure is force by area. Force I know MA MLT power minus 2 by area L square. By L is there because it's a pressure gradient. So by L whole power of A. Coefficient of viscosity dimensional formula I have already derived earlier. Please check that. Power of B. Radius is L length. Power of C. So as this is dimensionally equal, I can equate the dimensions of each fundamental quantity like length, mass and time on both sides. Let's write the final equation here. Here there is no m on left side, so m power 0, L cube, t power minus 1. K don't have any dimensions because that's a constant. M, this L and L can be cancelled. L in the numerator becomes a minus 2, t power minus 2 whole power of A. That is of pressure gradient. ml power minus 1 t power minus 1 per that's of coefficient of viscosity. This is radius. Now let us equate the dimensions of each of the fundamental quantities. First let's equate the dimensions of mass. Here the dimensions of the mass on the left hand side is 0. Here it is m power of A is there. Here m power of B is there. Here there is no m. So on the left hand side 0 dimensions of mass. On the right hand side m power of A, m power of B, and there is no m here, C. So A plus B is 0 and hence A is equal to minus B is one understanding I have got because by equating, how I got this? By equating dimensions of mass. Now let's equate the dimensions of other parameters like dimensions of length. Now by equating dimensions. So mass is over, then I can equate the dimensions of length. Yeah, let's equate the dimensions of length. On the left hand side, it is 3. On the right hand side, minus 2 and a, that is minus 2a. On the here, it is on the coefficient of viscosity minus 1 and b, minus b. And here, I will power c is there, plus c. So all that gives an equation minus 2a minus b plus c equal to 0. But I have already found that minus b is equal to a in the previous case. So in the place of minus b, I can write a. So minus 2a. In the place of minus b, I can write an a. That is plus a. Plus c is 3. Then minus a plus c is equal to 3. That's one more understanding we have got. That's when you equate the dimensions of length. Let's equate the dimensions of time. Let's equate the dimensions of time. Here on the left hand side, it is minus 1. Right hand side, minus 2 and a, that is minus 2a. This is minus 1 and b, that is minus b. But I know that minus b is already equal to a. So minus 2a, the place of minus b plus a is minus 1. That implies minus a equal to minus 1. That implies a equal to 1. Well, we got the value of a is 1. Once I found a is 1, as a is equal to minus b, b becomes minus 1. And let's substitute the value of a in this equation. This left hand side is 3. In the place of minus a, I can write minus 1 plus c. So the c value is plus 1 becomes positive on the other side, that is 4. So I got the values of all a, b, c's. Let's substitute these values here in the original equation that we are looking for. Yeah, what happens then? Volume per second rate of fluid flow as per the Poiseuille's equation is constant. Pressure gradient power of a value is found as 1. Coefficient of viscosity power of b, that is equal to minus 1. Radius power of c, that is equal to 4. This constant value is pi by 8 based on experimental results. So pressure gradient eta power minus 1 radius power 4 is the rate of fluid flow as per the Poiseuille's equation. That's volume per second is pi p r power 4 by 8. Eta will come to the denominator. Yeah. This equation is called Poiseuille's equation, which tells you that for a given cylinder, viscous fluid travels in this way, that directly proportional to pressure gradient and directly proportional to fourth power of the radius. That's how we find out basing on dimensional analysis, or we understand or analyze Poiseuille's equation basing on dimensional analysis. Thank you for watching.